Today I'm looking at M3 International A-Level January 2017. This is question 7. A hollow sphere has internal radius r and centre O. A bowl with a plain circular rim is formed by removing part of the sphere. The bowl is fixed to a horizontal floor with the rim uppermost and horizontal. The point B is the lowest point of the inner surface of the bowl, and the point A, where angle AOB is 120, lies on the rim of the bowl, as shown in figure 4. A particle P of mass m is projected from A with speed u at 90 degrees to OA and moves on the smooth inner surface of the bowl. The motion of P takes place in the vertical plane OAB. Find in terms of M, G, U and R the magnitude of the force exerted on P by the bowl at the instant when P passes through B. And this is worth 8 marks. Okay, so if we start looking at two things. One thing is we can look at energy to get a connection between the speed here and the speed here, and that would be useful because with circular motion your acceleration will be v squared over the radius, so we can then look at the forces exerted on the particle when it's at B and do Newton's second law and then use that expression for v squared as part of the acceleration. Okay, so the very first thing that I'll do is look at energy. So what I'm going to say is that the kinetic energy at A plus the gravitational potential energy at A will equal the kinetic energy at B, and so basically I'm taking this level to be the level where there is no gravitational potential energy. So the kinetic energy at A will be half times the mass, and in the question they did not mention the mass at all. Did they? Oh no, yes they did, here we are. The mass is m, so the mass goes there, multiplied by the speed, plus the mass times g times the height above b. So that will be r plus this part here. So if I've got that this is 120, then I know that this part here is 60. I know that this length here is r from O to A, and so therefore this height here will be r cos 60. And that will equal half times the mass times v squared, where I'm letting v be the speed at B. So first of all I can see there are m's everywhere, so I can cancel. Then I'm interested in v squared, so I'm going to double everything, so double, 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 and so I end up with u squared plus, taking an r out of here, I've got 2gr, 1 plus cos 60 is a half, so actually here I've got 3 over 2 equals v squared. And here I could even cancel these 2's, so it actually comes out to something a little bit nicer than that, u squared plus 3gr. Okay, and that's as far as I can go with conservation of energy. So then if I look at what would happen to the particle when it's at B, so when the particle is at B, then I would see that there would be the weight acting on it downwards, there would be the reaction force of the bowl, which is what I'm looking for, and then it would accelerate towards the centre of the circle with an acceleration of what I've called v squared over the radius, which was r. You can see that there. Okay. So doing Newton's second law, then I get r minus mg equals the mass times the acceleration. And so then I get that r is mg plus m over r multiplied by v squared, where v squared is this thing. So just tidying this up a little bit, I get that r is, here I've got one lot of mg. When I multiply this and this bit, the r's are going to cancel, so I'll get 3mg. So 3mg plus 1mg makes 4mg. And then as well as that, I'll get this little thing, so m times u squared over r. So that is your answer for part A, which is worth 8 marks. Now in part B, it says find in terms of G, U and R the greatest height above the floor reached by P. Now, because you've already got quite a lot of information about what's happening at B, you might be tempted to say, okay, well, the kinetic energy at B, all of that will just become gravitational potential energy. But what you have to remember is that the particle is not being projected from B with that speed that you've just found, v. So it's not the case that it's being projected up with v and then it just reaches a particular height. Instead, you've got these kind of two sections of motion. One is it's following the circle here up until this point here, and then it will move freely under gravity. So what we need to do is look at what is happening from here, where as it leaves the sphere, to that greatest height. And there we can use the constant acceleration equations because it's moving freely under gravity. So in fact, we'll get something less than if you did the kinetic energy there equals mgh and you worked out h. Okay, so that doesn't work because it's not being projected straight up, but it's moving around the center of around the circle and then moving freely under gravity. Okay, so looking at this part then, B. So as it leaves the sphere, okay, I had this diagram before. So before it was projected from A in this direction, so now it's going to be moving essentially in this direction. And I can see that's 60, that's not 60, that's 60. And the vertical velocity will be u sine 60. Okay, because what will happen as it moves around the circle is here it's going with u, here it's going with v, and all of the gravitational potential energy that I had at A kind of went into making this speed up, but then as it moves around here, it's going to get all that gravitational potential energy back, and the speed will slow down back to u. So that's how I know it's going with u over here. Okay, so then I know at the greatest height, then the final velocity will be 0. I know that vertically the acceleration is negative g, as I'm taking upwards to be positive and down to be negative. And now I'm looking for the greatest height. So I can use the equation v squared equals u squared plus 2as. And so I get 0 equals, now sine of 60 is root 3 over 2. And so squaring that, I would get 3 over 4 u squared. And here I get minus 2g, and let's call the height h. So then I need to just rearrange this to work out h. So I'll pop this on the left hand side, so I'll get 2gh over here, 3 over 4 u squared, so then I divide both sides by 2g, and so I get that h is 3u squared over 8g. Now, the question was asking the greatest height above the floor reached by P. So the height will be whatever height it's already at, plus this value that I just worked out. Now I can cheat a bit because I already worked out what the h was here, and so I found out that it was r plus r cos 60, which turned out to be 3 halves r. So I've got height above ground will therefore be 3r over 2 plus 3u squared over 8g. So that answer for part B is worth 4 marks, and now I'm given that u is greater than this thing. Show that after leaving the surface of the bowl, P does not fall back into the bowl. So if I look at my diagram again, so once it leaves the surface, then I need to show that it was going so fast that rather than doing a kind of pathetic whoa, it will go bidding over here. So I basically need to show that the horizontal distance covered will be greater than this distance here. So P will fall back into bowl if horizontal distance covered is less than. Now looking at this little diagram again, so this was OA, so this part here, if that's R and that's 60, then this is R sine 60, and so that's from the rim to the center of the bowl, so then I need double that. So I've got 2R sine 60. And sine 60 is root 3 over 2, so I end up with root 3 multiplied by r as the horizontal distance that it needs to cover in order to kind of meet the edge of the bowl again. So I need to show that the distance covered is greater than this. Okay, so if we look at horizontally what's happening, so vertically I had this, and so then horizontally I'll have u cos 60. A will equal 0. S is what I'm interested in. So then I need some information about T. And what I could do is use these values, but not with v is 0, but with v is minus this. So in other words, if this is the speed it goes up with, when it's got that same speed coming down again. So vertically, I would have u sine 60, v is minus u sine 60, a is minus g, and then I could use that to find t, and then pop that value of t in there. So if I use v equals u plus at over here, then I get this. Sine 60 we said was root 3 over 2. Here I get minus g times t. So popping this over here, I get minus root 3 u equals minus gt. I'll multiply both sides by -1, and then I'll divide by g so that I just get what t is. And then I can pop this into here using s is ut plus half at squared. So s is ut, so u cos 60 is a half, and t is this thing, plus half at squared, but the a is 0, so this will be what s is horizontally. Okay, so here I get s is ut squared times root 3 over 2g. Now, what was the information that they told me? They told me that u is bigger than this. So if I rearrange this to give me u, then I get 2g over root 3s is u squared, and then squaring this, so if u is bigger than root 2gr, then that means u squared will be bigger than 2gr, and therefore this thing is bigger than this thing. 2gs over root 3 is bigger than 2gr. So dividing both sides by that, then I get that s is bigger than root 3r. And in fact, here I said my hypothesis was that p will fall back into the bowl if the horizontal distance covered is less than this. So therefore p will not fall back into the bowl. Okay, so that part of the question is worth 5 marks. I hope you found this solution helpful. Do click like if you liked it, and good luck with your revision.